All right, 9.5. We were about to conclude 9.5, almost done. Except one question left. That was number 4. Why don't we go review what we did on Friday first? We started solving, basically graphing linear equations, linear inequalities, and system of linear inequalities. So we started with one inequality, only one, nothing else. And we applied these 3 steps to graph them. So to graph them first, you need to get y on the left side all by alone. Okay, we did that, and then you need to describe whether the graph, and then we are going to create an equation out of this thing and see if that equation graphed is going to be a solid line or dashed line. You basically take a look at whether you have an equal sign under this inequality or not, and if you see an equal sign, that means it was solid. If no equal sign, it is dashed line. Okay, and finally you graph that line, but there are 2 regions the entire space split into, upper part or lower part. You're gonna pick one. You pick the region above the line if the direction of the fish mouth or inequality is pointing towards y. You shade below the line if the direction is pointing towards x values. Okay, that was the deal. We started with single inequalities, and then we solved one inequality with 2 equations. But that was kind of simple because y was already alone in this question. And this is maybe the most common format of questions, as this is a general question, really solid question, because you have x and y together on the left, 2 inequalities first of all, x and y both on the left. So this problem will involve all 3 steps. You can't avoid any step here. You need to do all 3 steps on this question. Okay? All right, let's take a look at step 1. First off, there are 2 little problems combined here. So you need to first split off those questions into top one to the left and the second one to the right. And you're pretty much going to repeat the same steps for each question, left side and right side. Step 1, make sure y is already on the left isolated. Is this y on the left? Yes, but has it been isolated yet? No. We need to move this x to the right side, simply subtracting minus x from both sides. So it will go to right next to 2 or before 2 as minus x. Minus x plus 2. Okay? Let me know if you miss a spot. Look, minus x plus x cancelled, y alone, minus x plus 2 on the right side. I like x before the number, that's why I put it in the front. Okay? And I will do the same thing on this guy too. Subtract 2x, in other words, send this guy to over there. We will have y less minus 2x on this side plus 4. That was step 1. Here and there. Are we good? Step 2. We are going to graph the related equation. So for a second, think this is y equals minus x plus 2. Create a table and get 2 points on it. Connect those 2 points and extend. I mean, we will graph a line equation here. Just imagine this is equal sign for a split second. Alright, I will choose in x and y values. What do you want to choose x to be? What's our best value all the time? 0. When I enter 0 into x, I obtain y to be, y will be minus 0 plus 2, which is 2. Y will be 2, and I get the point 0 comma 2. Then you can continue choosing on x side like 1, 2, 5, etc. But I prefer choosing on the y side and computing x. What do you want to choose y? Best value again? 0. This time I'm choosing y to be 0 right here, and then I'm going to solve for x. But this is anymore. So once I set y into 0 and solve for x, I need to subtract 2 from either side. And x is multiply both sides by -1, so you can cancel that minus sign. Okay, and we will get x equals 2. 0, 2, 2, 0 are the 2 points you made. And we will graph it. We will graph this thing down here, those 2 points. Again, what are the 2 points we got? 0, 2. Where is 0, 2? 0, comma 2 is 1, 2 here. Where is the other one? 2, 0. 1, 2. Here is 2, 0. Let's combine them. Okay. Skinny one. I will combine them and extend. I will make it longer in the same direction, to the left and to the right. Is step 2 clear? This is step 2. Step 2, left side, says graph the related equation. I did. Is it over? No. If you read step 2 statement, it says not only graph it, but also determine if you're gonna make that graph in dashed or solid line. Dashed or solid. So which way is it gonna be? It looks like mine is solid. Is it right though? Is it gonna be solid? How do I determine that? Anyone?
Direction of the greater or less than sign.
Is it direction or is it something else? It's the equal sign or not. The direction, we don't care about direction yet until the next step, but here we see if you have equal sign. Do you see any equal sign? No, that means this line is so far incorrect. You graphed it right, but incorrect style. It needs to be dashed. Here we go. Now it's correct. Okay? That's step 2. Step 3, I will do it again right on the spot here. Step 3. I will use this picture again. What do we do in step 3? We are going to pick a side, either above the line or under the line, and color it. Now, this is above, this is under. Which side are we gonna pick? And why? And I will frame this so you need to use this inequality, not the original one given. Don't use this one. Always stick to this to make a decision. What kind of decision? You shade above the line if the direction of the inequality is pointing towards y value. If it is pointing towards x values, you're shading under, below the line. So which way is it pointing? It's pointing to the right side, x direction. So it is, we're shading below, correct? So let's do it. Okay, which color you like? Green? Alright, half the question is over. We are done with the left side. Now what is left? The right side. We are going to repeat step 2. We already did step 1. We left y alone. Step 2 is graphing the equation. Turn this into equation and graph it by choosing values in the table. So I'm going to do this part a little fast because it's repetition of the left side. X and y. I set 0 in x, I set 0 in y, and compute the other sides. If I set x into 0, here you go, 2 times 0 is 0, add 4, it's 4. If I set y into 0, subtract 4 from left side, divide by minus 2, it is minus 2. Where is the mistake? No mistakes?
It should be positive.
This is positive 2. Because when I enter here 0, subtract 4 from both sides, it's negative 4 equal minus 2x. Divide both sides minus 2. And that's positive 2. X is positive 2. Okay? So I'm just making common mistakes I see in the exams, so you can be aware. Alright. Now, there you go. This guy is gonna get its own graph as well. You need to plot these points. It's 0, 4. This is 2, 0. 0, 4 is, use the same scaling because you're gonna collide them, intersect them. So use same scale. Don't go and say 0, 4 is here. Don't make big scaling. Needs to be the same. If this is 1 unit, you need to use the same units here too. 1, 2, 3, 4, approximately here. And 2, 0, this is 0, 4. 2, 0 is, oh, it's this point as well. They coincide, correct? Let's connect those lines. And tell me, is it gonna be a dashed line or solid line? Dashed, because it's less, not equal sign present. Again, this is always what we refer to in making decisions, not the original. So it's dashed because of the strict inequality. Alright, let's pick our line. This time let's go with blue. That one. Didn't happen. Where's my dashed line? There we go. Okay. Which side are we gonna color? Above or under? In purple. Above or under? Where do you look at for this? Again, this guy. It's pointing towards X values again, same reason. It's under. We're going with under here. And use different orientation. If you used vertical lines to color this shade, make horizontal ones here so you can see the difference better. Okay? Now we are gonna move these two guys together into the same picture and see where the intersection will happen. Okay? Alright, I'm going to move the right picture to the left. You can do left to right if you wish. I'm gonna move the right picture to the left side. Hope it's gonna work perfectly fine. Nope, 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 I don't want everything. It's gonna be tough. Maybe you need to make a picture it's, from scratch. All right. Okay, just move side by side. All right, I moved everything. Almost. There you go. And I'm missing these three pieces. They left out, okay? Now, we are ready to make the final coloring, which is going to be the overlapping area. You need to describe me what's overlapping between purple and green regions. So, is it here? Why? I see purple and green everywhere here, right? It's no. Of course, because here on this part, I see only purple, not green. It must be both colors. So I skip this part. I see green and purple here. And we go color all this area, right? And this is it. This is what I'm going to pick in the homework. Agree? Agree? Now again, I overdid it again. This part I see only green. Look, no purple touching here. So these are the mistakes. I mean, trust me, you feel like, oh, this is so easy, I won't make a mistake. But no, trust me, I will see exact same mistake in the exam. I can bring it after the exam if you want. Copies of those exam papers. You will color this and that. But no, the right picture is under red line up to here and then under blue line under here, not anything more than that. Take anything exceeding here. Okay, it looks like, but these are not included into my region. I'm just cleaning up. Okay, let's pick it. Any questions? Simple, right? Look, I have some tools, like moving everything to the left is great, but can you do it on your paper? No. So you need to really slow down and think, visualize when they match, where do they overlap? I make it easy here on the screen because I have some tools, great tools. All right, let's go. We need to answer several parts before coming to final answer. First, is this a dashed line or solid line? It's a dash. Both were dashed, right? Check. Graph each line. There are two lines we need to graph. First blue one was 20 and 02, right? So it's opposite color than what I picked here. First one was 02 and 20. The second one 40, 04 and 20. Next. Alright, we are going to pick the right option here. Wow, 8. So you can't guess this. You have 1 out of 8 option to make it right. Which one? A, B, C, D, E, F, G, H. I'm slowly going up and down so you can pick. B, it's here my picture, here's B, here's my picture, here's B. Looks like my colors are different, blue and red, but it's B. Are we done? Yeah. Okay. Inequalities is over. We are going into a different ocean now. This section is over, chapter is over. Any questions? Okay. We are going into a chapter that's very profound, very important. Okay? This upcoming chapter is about factoring polynomials, factorizations, factoring stuff. We are gonna see in all the rest of the section that factoring skills. We will keep using it once we learn it. Not in this course. Next course, 1148, you go, college algebra. You will use these skills there. So make it, this section, make it, give your best effort and learn it best, okay? So don't try to just answer questions, but try to learn it in the long term, okay? So it is chapter 6 we're talking about here. It's a very long section, first one. We will continue this next time as well, but we are going to learn our brush up. If you already have some factoring skills, we're going to brush them up and learn more things, okay? Here we are. We first start with something called greatest common factor. Greatest common factor. First of all, we need to explain what a factor is, so then we can see which one is greatest, right? Do you all know what factor means? Let's talk about numbers. Look, there are some numbers, they are small, like 1, 2, 3. There are some numbers that are kinda medium size, 10, 15, 20. What decides them to be small and medium? I mean, when you try to convert the numbers here on the screen, some numbers can be a product of 2 or more other numbers, such as 15 can be turned into 3 times 5. You see, it's product of another 2 numbers. But however, you can't do that for 2. 2 is again product of itself and 1. This is not really a product of other numbers. It's itself and 1. 1 and itself doesn't count. Forget about 1 and itself, all right? But can you find other numbers than itself and 1? For 15, yes. For 2, no. Okay? And for 3, no as well. For 20, yes. 20 can be made. Anyone? Can you write 20 as product of 2 or more numbers? 4 and 5 maybe, right? And even 4 can be split further into 2 and 2. So 20 is actually a triple product, 2, 2, 5. And most of the time we will try to break it into the pieces that are no longer breakable. So for example, you broke it into 4 and 5, but 4 is breakable, still breakable. So you continue breaking 4 and you make double 2 and 5, okay? So we this is called prime factorization. And these numbers that are not breakable is prime. Did you know 2 was a prime? Most people think even numbers are not prime. No, there is an exception. 2 is a prime, but not 4. Yes, you're right about 4 because 4 is 2 times 2. It's not prime because it's breakable to another number other than 1 and itself. 10 is not prime, 15 is not prime, but 3 is. How about 29? Can you break 29? 29 is not breakable. You can only multiply 29 by itself, and 1 and 29 itself. So 29 is prime. So its prime factorization is actually 29 and 1, but 20 is something else, 2 to 5. Okay? Now, question is, you can break one number into its factors, and you can break another number into its factors, and you have many factors you get. Question is, which one of those numbers are common in both numbers? Not only common, but also what's the greatest common factor among them? Okay? So that's our issue, and that's our first question. Find greatest common factor of 30 and 63. You probably have a different pair, but the same idea. Here's what we do. You first take each number and break it into the smallest factors possible. Start with 30. Some people can do it right on the spot, write it down everything clearly, but I can't. I'm not that smart. So this is what I do. I call this a branching option. First, just break 30 into any two numbers that comes to your mind. Any two. What two numbers that comes to your mind? 30. 3 and 10. Perfect. Could it be 5 and 6? Could it be 5 and 6? Yes. Could it be 15 and 2? Could it be 15 and 2? Yes. So there is no unique way. You can come up with any two pair. But your friend said, you said 3 and 10, right? We start with 3 and 10. And always take a different color on the side and do this to answer this question. Every time you get a pair of numbers, is the number on the left further breakable? Is 3 breakable? I mean, is it a prime or not? Is 3 a prime? Yes. Then lock it. Red means we lock it. That means you will never ever be able to branch it out. No more branches coming from 3. It's a dead end. End of road, okay? End of road for 3. You give up on 3 side. But 10, is 10 breakable? Yes, it is. I can break it into another 2 number other than itself and 1. Don't choose 10 and 1. This is ridiculous. Don't choose itself. It should be always some other number, which is 2 and 5. Now take your famous color again and mark. Can I break 2 more other than itself? No, it's prime. Lock it. Dead end. 5. No, lock it. Dead end. Once you end up with all dead ends, it's time to write up your prime factorization. Have all those red circle items, search and find them. It can be in previous steps above like here 3. Collect them all here. 3, 2, 5. However, when you are doing that, choose from smallest to biggest order. So I don't like 3 coming first. I will choose 2 first, 3 next, 5 later. This is a mistake-proof method. You can't make a mistake if you have been following my directions. Take different color, lock, continue or stop. No brainer. But can some people avoid this and do it right in 1 second? Yes, there are people that can do. Okay, here, right? Okay. How about 63? If you can write it, immediately do it, but I will, for first couple questions like this, I will do it slowly. Pick two numbers multiplying into 63. What two numbers? 9 and 7, right? Or 21 and 3, right? Okay, 9 and 7 makes more sense. Alright, take your favorite color. Can I lock 9? Can I lock 7? It's prime, it's not breakable. That means 9 keeps going on to what? They are both locked, and we're done. Double 3 and 7. Okay? Now, any questions? Alright, are we done with factoring? Yes, but now we are going to check out what's common between these factors. So frame this. This is your what you need to focus. Focus on this and focus on that. Too big. Look at these and mark the stuff that's common on both rows. What's common? 3. Only one pair of 3. That's the only thing common, right? Okay? Since you have only one item common, one thing common, can you pick the greatest of all these items? It's just one item. What's the greatest of all factors, common factors now? It's just 3, okay? So we don't have an option here, just say 3 is the common factor here. That's it. We will do one more question here. Here you may have more than 3. Let's see. Alright? And okay, let me first finish this. That's the correct answer. But hypothetically, I want to switch the question. What if you had, what if scenario, this is not correct, but I want to put a squeeze in a 5 here. What changes now? Now, how many common items do we have? 2. One of each kind. 3s, let me different color. 3 and 3. And 5 and 5 are common, right? How do I find the greatest common factor now?
It's 5 because 5 is bigger, right?
Yeah, that would be my answer as well. However, no, we're not just picking the bigger of these. We are actually taking one from each kind, one from each side. So you pick one of these 3s, and then you pick one of these pairs, one of them, 5, and guess what you do with them? You multiply them out, 15, and that's your new greatest common factor. To find greatest of common factors, you multiply, you pick one sample from each common and multiply them, alright? But your friend's idea was actually makes sense, right? You would pick with whoever is greatest here. But no, they are not saying greatest of prime factors. It's not saying prime factors. Yeah, greatest of all prime factors is 5. But it can be also combination of those numbers and make non-prime factors. So we multiply, combine those prime factors and multiply and make 15. But this has nothing to do with the original question. Original question is 3. We go to next one. Hopefully we will have more than 3 here. No, maybe not, because we have 3. Anyways, what's the difference here? We have 3 numbers you need to break and compare. Usually, when you go out with a friend for a movie night, if you go with a single guy, not a single guy. If you go with a single one friend, is it easier to go into movie night, or if you go with two other friends and picking a movie everybody likes? Which one is easier? I mean, you're a group of 10 people. Can you all agree on one movie title? No, some people like romantic, some people like action, right? Same deal here. Usually if you have more and more number, greatest common factor tends to be smaller and smaller, but let's see, okay? Because less and less stuff will be common. Anyways, 30. Have we broken 30 before? Yeah, we did. Can I cheat? What was 30 factors? 2, 3, 5. 2, 3, 5. How about 45? I need to do a brand new branching for this one. It is 9 and 5 first. 9 is 3 and 3. 5 is like 3, 3. Right? So it is 3, 3, 5 next. 48. How do you break 48? 8 and 6. Or 4, 12. 16 and 3. No, it's not 16 and 3. Yeah, it's 16 and 3. Okay. Can I break 8? Yeah, 4 and 2. How about 6? 2 and 3, or 3 and 2. These are locked. Not 4 though. 4 is 2 and 2. So how many locked circled numbers? 2, 2, 2, 2. Quadruple 2. And then 1, 3. Okay. Do you see a factor that is common in all 3 rows? Such as we have a lot of 2's here, but do you see 2 in everywhere? So 2 is not a common factor. So I'm not marking it. 2 is not a common factor because it's missing in the middle. Let's go to next one. 3. Is 3 everywhere? Next, I see 5. Is 5 everywhere? Nope. You have only one kind again. You don't have to multiply with another thing. It's just one kind. So you just put 3. Oh my god. Same answer. Maybe we should put 3 in the next answer as well. Maybe it's a pattern. Who knows? No. It's too much. Alright. What is different in this question? Yeah, we have variables now. I wish these were gone. And the question was only 28 and 21. I would just repeat the same steps, right? Trust me, I will still do the same steps. First, break 28 and 21. And ignore these numbers. What were they again? M squared n and m cubed n. Simply break 21 and 28 and 21. Ignore these, okay? How do you break 28? 7, 4, locked. 2, 2, lock, right? It's 2, 2, 7. Okay, but unfortunately 28 is not alone. And what do I do with m squared and n? Yeah, I will move them here, but instead of m squared, I will split it into each factor m and m, double m, because square means double, right? And n is single already, like that. For 21, I first break 21 into 3 and 7. Can I break 3? No. 7? No. So it is 3 and 7. What do I do with m cubed? Triple m and a single n. Just want to make sure. Yep, single n's. Okay. Let's take your matching color. Pair up the items that are matching in each row. Do you see 2's? No. 2, no. How about 3 below? Do you see up above 3? No. 7. Yes. I see a pair of 7. Circle them. M's. Any matching M's? 2 of them. So circle the maximum quantity. Double M. Not triple. I'm not circling this. Double M matching. Any matching N's? Yes. N's are matching. Okay? Now, how do I find the greatest factor? These are all common factors. 7 common, M squared common, N is common. So there are 3 common factors. 7, M squared, and N. What is the greatest it's gonna make? All you need to do is pick one row, top or bottom, and multiply either one. Top or bottom, not both. So it is multiplication of one sample of each common factor. One sample. Don't take both samples and do 7 times 7, 49. No. One sample from each kind. So I have 7 coming in. From these pairs, I have this sample, which is M squared. And from this pair, I have this sample, which is N. So basically, you're multiplying the circled items either on the top or bottom. 7M squared N. That's greatest common factor. Okay? But again, some people can do it right here. What is the biggest number that divides 28 and 21? They can do it 7, right? 21 has 3 times 7. 28 has 4 times 7. It's 7. What is common between M squared and M cubed? At least 2 of them matching. They put here. What is common between N and N? 1N. So they can get to the same result kinda by using smarts here. This is kind of risky. It's fast. I recommend it. Do it. But always, if you have time, do this kind of pairing, matching, and multiplying. Okay? 7M squared N. Any questions? So it has nothing to do with 3 then. Do you know how to make a square, right? You can use this button as well. Always, if you want to go to the floor from the exponent to the top, use arrow keys. It's easier. But you can use the mouse too. Okay. See what's coming up next. Okay, we're gonna make an observation next. It's called distribution law. This is a very useful law. When you have a number multiplying an addition inside the parentheses, you simply distribute that number to the first and second terms. You put A and B first, and then you put A into C next, and you keep this sign in between. Okay? We usually do this backwards. Again, you have a parentheses, you have a number in front. We always so far did distribution. 3 times x, 3x, 3 times y is 3y. In this section, in this chapter, we will be given this. You will turn back to this stuff. So far we were going from left to right. Now you will be going from right to left. They will give you 3x and 3y. Can you make it a parenthesis sum of 2 items and a number? Okay? And here is a version which is one number, one item versus how many items? 3 items here. 1 distribution over 3. You distribute to the first, you distribute to the second, you distribute to the third. Can you do it backwards though? There are 3 items. Can you make it back 1 item versus multiplication 3 items? That's our interest coming up next. And here are the steps we need to follow to go back from here to here. These are the steps we are going to make. And we are going to start with a very easy question. Then we are going to start doing something more complicated. But this is easy. Why is it easy? How many items do you count here? How many? Just 2. So it's kinda this way. 1, 2. All you need to do is find GCF of each item. Item 1, item 2. You need to find, first of all, in math, we don't call them items. We call them terms, okay? So I've been calling it item, but term 1 and term 2. Find GCF of each term. Term 1 and term 2. So I need to factor these guys first and then find GCF, right? Identify greatest common factor of all terms in the polynomial. I have 2 terms. I will factor them. How do you factor 2? Can you break 2? Can you break 2? No, 2 is already simple enough. Can you break P? It doesn't have any power. It won't. How about 4? Can you break 4? It's 2 and 2, right? And there is no P here. And take your green color and see what's matching on top and bottom. What is matching? Only 1, 2. This is common factor. But it's not only common factor. Since it's the only one, it's also the greatest common factor. So the GCF is that factor too. It's not 4. People multiply this again. You are taking only 1 from each side. 2 is the GCF. Okay? Now, how do I... Okay, we already did this step. So this is step 1. Step 2 is write each term as the product of GCF times another factor. So this was step 2. So when you're computing GCF, you're actually doing step 2 as well. But you need to put these 2 here. So 2p plus 4. Write this 2p plus 4 as 2 times p plus 2 times 2. And mark that GCF you've determined. It's 2, correct? I figured out it's 2. I'm marking it. Now guess what I'm gonna do? I will separate this and put it right here. I will borrow $2 from each guy and put it here. It's kind of tax. There are 2 families here. Each family is giving me same share, 2. They are giving away 2 from their family, okay? The question is, what is left in each family? I see a plus left in between them. But what is left if you already government taking these guys? What's left in each family? It's like recruiting soldiers. 2 went to a tour. Who's left in each family? P here and 2 there. This is called this is step 3. Recruiting one common person from each family and collecting leftovers in the parentheses, leftover items, is step 3. It's called distributive property, and we actually recruited, I call it in recruited that soldier from each family, which is 2, common thing, okay? And everybody gives the same person. Got it? So this 2 times p plus 2 is how we factor out the GCF. GCF is here, and leftover items in each term or item is inside parentheses. Now how can I check back I did everything right? This is optional part. They say here, if you want to make sure your factorization is correct, you simply redistribute like it's discharged. War is over, this guy is going back to families. 2 will go back to first family, the other 2 will go back to first family, and it's gonna make 2p plus 4. Okay? Did we get the original? Yes. So I'm sure this is right then. Whoa. Why do... Which question is this? 5. Okay. So we skip this one. That's another GCF question, okay? So this expression is what the heck prime means? We call an expression prime if there is no GCF other than 1. Did we found a GCF other than 1 here? Yeah, it's 2. It's not 1. We found a solid person you can remove from that each family. So it's not prime then. It's not prime. And what is that factored form we obtained? It's 2 times P. We remove 2 and we keep 4 as it is, right? We don't touch 4 because it's 2 is next to P, correct? Now 4 also lost at 2 and reduced to 2 plus P plus 2. Any questions? Okay. Now I want to shortly mention what's in number 4. It's basically almost number 3, except instead of two terms, 2 items, you have 3 items, a third item. So you need to look at what's common in everywhere, in all 3. Can anyone do this on top of their head? What's common between 3, 6, and 18? 3, 6, and 18. 3. How about between r cubed, r squared, r to the 4th? What is the biggest you can borrow tax each guy? R squared. Among S's, first family has double S, second family 4, the last one 6. What's the most you can tax everybody? S squared. You can't go more than the S squared because first family doesn't have it. The last one, T squared, T to the 4, T to the T squared. Everybody has at least 2 of the T's. You see, you can do this on top of your head. But otherwise, you need to take your green color and match how many each has and multiply them all. Alright, and you come back next time, we will do more solid factorings. These are all introduction beginning, okay? So make sure you signed up. I'll see you tomorrow.